there are people who are working on stuff like that in order to predict whether this drug is going to work for you, given what your genetics are. Your tumor had these problems. Your tumor is mutated on this and this and this. We're going to make a prediction about these 10 drugs. This one's going to work best.
Welcome to another episode of Tools, Talents, and Techniques. This week, I am very excited to be joined by Mr. Dexter Pratt, who has a very distinguished background. So I'll let Dexter introduce himself. So Dexter, welcome to the show.
Thank you, Dustin.
So before we jump into the meat of things, could you just briefly say who you are and a little bit about what you currently do?
Okay, good. Well, so currently I'm at the University of UC San Diego, actually in the School of Medicine. I do research there, and I've working back from where I am right now. I've recently taken a hard left to be pure research, and I'm getting my doctorate. So
congratulations!
Strangely enough, on my journey in industry, it was just never the right moment. So here I am, but I'm having a ball. The world changed for me with the generative AI coming out. That I suddenly realized that there were things I'd wanted to do for 40 years that I can do, and that it was so exciting. And so instead of retiring, I'm going to be doing research for quite a while, I think.
All right. Well, congratulations. Soon to be Dr. Pratt. And a big part of why I was so excited about having this conversation is because I know from our previous conversations that you have been interested and involved in artificial intelligence for a very long time.
Yep. So back in the 60s when I was a kid, I was just totally fascinated with robots and spaceships. But I read a lot of robot comic books, and then I got a little bit older, and I read a bunch of Isaac Asimov, I, Robot. And as I was telling you earlier, somewhere there's a drawing by me when I was 7 years old, a schematic for a robot that actually had some kind of mechanism inside. But sometime after I graduated from college, I initially was working in a company that was doing solar cell research. And I was okay, but I had an epiphany one moment. I said, I've always wanted to do either robots or spaceships. NASA doesn't look like that much fun right now. It's a lot of bureaucracy. So I talked my way into the MIT AI lab and got a job being a technician, helping to put together, be essentially the one-man assembly line for these computers that had been designed at the AI lab. This is about 1980, as artificial intelligence workstations. And these were some of the first things that were actually workstations. I had the enormous privilege of learning to program, learning how to use machines on a machine that was like 10 years ahead of its time. Things you take for granted nowadays, they worked on this machine. And so that was great. And I got caught up in that startup company, one of two startup companies that spun out and tried to commercialize this technology. And it's an interesting set of stories about just how they almost had it in their grasp, both companies. And we didn't see what needed to be done. We were caught up in our mindset. And so they didn't make it.
Well, hold on. Before we go any further, let's put a pin in that for a second. You're saying that you were working in an artificial intelligence lab at MIT in 1980?
Yes.
So before that, let's give the audience and myself a little background. So you went to college at Yale for undergrad, correct?
Yep.
What was your major in
I was a chemistry major.
Chemistry major, okay. And you had this And then you got in the. It's amazing to me that there was an artificial intelligence lab in 1980, and you
Oh,
were working on this back then.
oh no, no, no. People really don't get it how old artificial intelligence is. And so, I mean, it goes all the way back to the origins of computers. One of the critical people in the history of computing is Alan Turing. And Alan Turing was one of the people who was critically responsible for the machine that broke the German codes in World War II, the British machine that broke the German codes, and was instrumental in some of the large victories at the end of the war. That machine was one of the very earliest computers. At that time, he was already thinking he and others, but he in particular came up with this proposal of like, well, if you achieved intelligence with a machine, some machine in the future, which was much, much more than what we can do now, how do you decide it's intelligent or not? And so there became what he called the imitation game. And so it was, if you could pretend to be something, to be a human, and the person on the other end of the typewriter or the telephone can't tell that you're actually a machine, then in some sense you passed the test. If you can quack like a duck, then for all intents and purposes, you are a duck. And so just recently, just a new announcement out of a group at UCSD here in town, they had published something last year where they tested ChatGPT and a couple of the other ones in attempting to have a dialogue with somebody and try to pretend to be a human. And then the humans were judging who was a human and who wasn't. And they had a set of people as the control group. And so they recorded those results. And just yesterday, they updated their results with using the latest model, or one of the latest models from OpenAI. And they said, okay, with this model, now we're up to 74% of the people can't tell the difference between humans and this chatbot better than even chances. So, so what does that mean? Like at what point do you decide things are intelligent? Anyway, so that's all the way back in World War II, trending into the 50s. Tragically, Alan Turing was gay, and at the time that was illegal. And after that, he became exposed for that. He was persecuted and forced to take chemical sex suppression drugs, and ultimately he committed suicide.
Wow. So
that's a fairly grim start to grim end for somebody who is now, one of the early visionaries of the field. Anyway, fast forward into the 60s, and computers started to be something that had some amount of memory and power for them. They weren't, the things that were computers in the 1940s, they were about like 0.1% of the old Fitbit that you have in the back of your closet. By the time we get to the 60s, we have something that, it had kilobytes of RAM, thousands, small thousands, not large billions. And so basically, you now carry in your pocket every day something that is far beyond a supercomputer was back in the day. It's you're harnessed correctly. Your phone could be a weather prediction system crunching huge numbers at the level they did for weather prediction back in the 70s or 80s. But in any case, they were already thinking about how to manipulate symbols, how you can do logic, how you can say, well, if it can think, let's make it, have rules for deciding what its plan is, and have a set of rules for, well, what are all the things in the world? Well, there are things that are matter and things that are not matter. And then, get all the way down to, hey, here's the concept of automobile. And then my automobile is one instance of the concept of automobile. Things like that. And they thought, we just have to do this well enough. We have to scale it up, make a big enough system. And we're going to do it. We're going to achieve something that is thought. And one of the problems is that, let me start by saying, after I stopped working for that company that made this advanced hardware for running AI, I got a chance to work at a commercial research project in Austin, Texas, run by a guy named Doug Lynott, and who was in the early 80s, he was one of the people who was a great innovator in what were then called expert systems. They're called that because the idea would be that you could work with an expert in the field and you could get them to tell you all the rules. If we're diagnosing this patient, if they have this but not that, then, and that would capture all their knowledge. Well, he got a chance to scale things up big. He got a pile of industry money. He actually got enough money that other people in the AI research community were, they said nasty things about him, because partly because they didn't agree with his positions and partly because they were jealous. So I got a chance to work on that project, and we ultimately had a system that was, even with late 80s, early 90s computing, there were about 1 million objects in it, 1 million facts and rules. And I used to go home and say to my wife, well, I know I did a good job today because I feel so stupid. Because it just turns out that writing rules on that scale, people aren't smart enough to do that. They just get too tangled and too huge. There are still things around that are expert systems, that are rule-based systems, and they can do some things really well. There are rule-based systems that work every day for you in, like, the healthcare system where you go to the doctor, and there are triggers that do, for particular purposes, identify cases where, like, it should ring an alarm bell. They're specific cases. They're not like a general thing. My wife, Margie, works recently retired from a company that does fitness and diet recommendations based on getting blood samples from you and other data. And that system was all powered by rules. And Margie was very involved in developing a lot of those rules, working with both the programmers and the dietitians and all. But that's where that set of rules is rated sort of the limit that people can maintain.
So when you're working on this project and you have all these rules, and you've mentioned that a couple of the startups previous to this didn't quite make it. In your opinion, was it because of the specific use case that they were focused on? What were the things that they were missing out on that didn't allow them to hit their mark?
Those companies failed to make it because they didn't, being in one of them, just didn't get what the market was, how to make it work as a business proposition. The technologies and the ideas that came from that, they were hugely influential. And like I say, you use that stuff every day. There's parts of that were first, at the time I started with that, there was the research computer coming out of MIT and another research computer coming out of Xerox PARC, Xerox Palo Alto Research Center. They were the only ones in the world who had mice. That's where mice came from. The first mouse that I used in a system that had windows and mice and click on things, that's where I started at the time before there was a Mac, back when green screens and keyboards were it. And I was getting to learn how to do computing on a thing that had Windows system and mice, and that mice was built in a machine shop and was machined on a milling machine by hand. And so, so that's an example of something that came out of that technology. We were running a thing called ChaosNet to have the machines all connected together. Later, Ethernet, but this was before there was Ethernet. There was something that worked like Ethernet. So anyway, that was a bitter lesson when I got to go to this project, and we were trying to build this great thing that was going to be, like, we called it a common sense reasoning. It was going to be a massive common sense reasoning system. Today, you might say AGI, artificial general intelligence. And it just was like, nope, we're never going to get there. It's clear that people aren't smart enough to write these rules. And at the time, neural nets were coming along and people talked about them, but they were regarded by most people as a joke. Why? Because they're too small. The neural nets can do some interesting stuff when they're little, but there wasn't the computing power and there wasn't the data. So two things happened is, one, the computing power became insanely bigger. I mean, it's unfathomable how many pieces there are, how many little bits of dials you set in order to make ChatGPT do what it does, and how much compute it takes to run that thing. So it actually talks to you, back to you in real time.
What did you think back then where this could go? And where does that compare to what you're seeing now? Is anything that what you're seeing in the market or the world right now with AI, does it even resemble what you could have thought of then?
I was totally shocked at how the neural net technology and the generative AI suddenly leapt into being. And even the people who were creating it were shocked. They knew it was going to get better as you got more compute, as you made the models bigger. They weren't prepared for the sudden jump that they got from things that were kind of interesting, things that were trying to complete sentences, and to something that suddenly is talking to you, basically. So that was a shock to them. It was also a shock to me as soon as I heard about it. But the thing that, like I say, that there's stuff I'd wanted to do for 40 years. The trick was, for me, is that I would call the stuff that the neural nets do as the squishy bits. They're intuitive. They think fast. But they're not entirely reproducible, and they make interesting mistakes. It's hard to get them to do planning over long term, and it's hard to organize them so that they will be doing things in a repeatable workflow. Those are all concepts that are way, way old. People were thinking about those things, thinking about agents, where now agents is the big word. Yeah, the concept of agents is a 1980s concept. But we couldn't do anything with it. People had bright ideas about it, but you couldn't make it work. It just was too hard. So now you have these magic boxes that, will let you glue together stuff if you give them a logical framework. And so there's a lot going on now. On one hand, making the models themselves better at thinking through things logically. On the other hand, there's this whole array of problems that our people are tackling to have them continue to work, to remember who they're working with, what the problem was, what did you do last week. And those are really hard because, like, right now, Apple made a big set of promises last year about, oh boy, you better get the latest iPhone because we're going to have all this AI in it and it's going to manage your life. It's going to be great. They've had a number of problems, but the critical point here is that you still don't, from them or anybody else, have a thing that's like in your hand where you just say, hey, look at what's my schedule, and do you remember what I was doing last week? And that's still not there. In principle, these things ought to be just like Jarvis for Iron Man, right? Some things they do are insane that they can do them, but we still haven't gotten that piece where they can kind of remember over the long term who you are and what you're doing. And so that's where things are really getting. There's a lot of work right now that is pushing that direction. As soon as people start cracking that, there's a bunch of things that are going to happen very abruptly once they get past that threshold. So Microsoft also was trying to say, oh, we'll have Copilot everywhere with you. Mostly Copilot will summarize your, help you write something, summarize your emails, but it won't be your assistant in the sense of like having a human assistant who comes along and makes your life better by remembering everything for you and doing things for you. But it's coming. It's very hard to know quite when they're going to crack it. So one of the things that's driving the improvement is not just people figuring out how to orchestrate it, which is kind of the end that I'm pursuing because that's where my old expertise lies. But the models are getting better at certain kinds of things in ways that are not immediately apparent to you. If you're there using ChatGPT to help you write stuff, answer questions, you'll notice that things have gotten better this year than they were last year, sure. But not qualitatively different, right? It's not like suddenly, oh my gosh, it's like talking to my friend. And in programming, however, there's a couple of jumps that happened in the last 10 months. And that the amount of flawless code that can be generated by these things is astounding. That
the code for software programming itself.
Yeah. I mean, so if you let's see, Claude or Gemini are particularly good at this, but you can go and say, I would like to have a program that's a web page, a one web page that's going to be an interactive site that's going to take this data that I have here from my project and my spreadsheet, make me an interactive dashboard for it. And it's going to all just run in the web page and put that up for me. And I use Claude more than the others, but basically you can say do it and it'll put it up in a little frame next to you so you can try it out, or you can just run it in your browser from your local machine. And kabam, it's some beautiful dashboard customized for you for just this one thing, and you have it in 20 seconds. Now, it doesn't always get it right. But the things you can ask for and get, when it clicks, it's astounding. One of the ones that they demonstrated at Google, the last major Google announcement meeting, was a simulation of a Rubik's Cube that you could spin in place and you could manipulate it, and you could in a 3D model, and you could have it solve it. You could run a solver, and and you can say it, but I want it to be a 5x5 Rubik's Cube, not the regular one. I want to have it be a 10x10. And so this was a puzzle posed by a guy who I think is actually in San Diego, Matthew Berman. He posed this to Gemini 2.5 when it came out. He said, well, make me this. And in that case, he was, the wind was with him. One shot, it did this. And the what it would take for humans to do that, I mean, people can do that, but that's not an easy program to write. That is not an easy program to write. Now, on the other hand, you can find interesting cases where you're going along and you've been generating all this code, and suddenly you just cannot get that thing to get its head around some kind of, yeah, but if that bug is over here and it failed there, why are you expecting it to work over here? And you can wind up fighting with it for like hours trying to, get it to see something. And even when you wind up fighting with it for hours, you still wind up being done a lot faster than if you weren't using it, way faster. But it's really interesting to see their strengths and their weaknesses. But the strengths are getting awfully strong. So, I think a real threshold is people now talk about vibe coding. I don't know where vibe came, except that it's so laid back, which is you don't write any more code. You're there coaching the ChatGPT or Claude or Gemini. You're coaching them about what you want. And so there are now plugins to the developer environments. When you're editing code, there are these environments that have been around for a very long time. And actually, frankly, I was privileged to, back around 1982, use one of the very first programming environments where the editor assists you a lot. Well, there are now plugins for these environments where the model is equipped with a bunch of tools that include being able to edit files and run code, and you're there working on your code, except it's all you saying, okay, I like that, add those things. How do you think we ought to solve this? Okay, go ahead and do that. I'm not coding anymore. I'm coaching. So I stopped actually laying my hands on code at all about December.
Yeah. How do you think, where do you see the biggest impact of AI and what you've seen? Where do you think it's going to show up the most in the relatively near future? That's a big question, I know. It seems to touch so many different things.
Like I say, it depends so much on like when certain thresholds get crossed.
I think about this a lot. But I took an AI course through Cal Berkeley 2 years ago.
Okay.
And it was amazing, because I've been interested in it for a while, nowhere near to the extent that you've been involved in it. But from movies, from 2001: Space Odyssey, I've always had this interest in it. And when it really started to show up, I was like, I want to learn more. And one of the fun things about taking that course was seeing how people in other industries were thinking about it. Mm-hmm. People from the healthcare sector, people from advertising and marketing and economics. And there were just so many people that were like, this is my thesis and this is what I want to work on and what I want to build, from all different walks of life. And almost every single one, I was like, wow, I never thought of it like that. I was looking at it mostly from a commercial real estate standpoint. But when I started seeing the people that are in medicine and finance talking about it, I was like, whoa, okay, this is very, very powerful. So I know it's a big question, but I'm just thinking from what you see and your knowledge, what do you think is going to happen next?
Well, there's boring stuff that I could say that obviously if I'm getting so much productivity, that means that it's a bad time to be a junior programmer. I don't want a junior programmer anymore, right? If it takes more time for me to explain to them what I want than it does to explain to those things, then it's not helping. But let's have something more fun that would to think about. I mean, I think first of all, we're right on the brink of having the artificial friends world being cool and dangerous. That the name of the company, I'm not really interested in this, but there's a company that's producing avatars that you can talk to. You build your own interesting friend to chat with, and they've been getting traction with teenagers. And there's a lot of peril there, right? That why should I learn how to make friends if I can have an entourage, people who always think my jokes are funny. And everybody can have their own virtual entourage. And the thing is that just now, I think that company just started having not sort of a chat interface with a picture, but actually starting to have an avatar that I think they're right on the cusp that these things are going to start talking to you, and I think that a younger audience is maybe much more forgiving about having it be glitchy, maybe not a perfect human simulation at first, so that and not necessarily being always logical. That's okay. We're just having a chat. It's okay if my friend is sometimes a little ditzy. Well, that's potentially really psychologically isolating. All the problems where you have people who get obsessed with their video games and wind up cratering. I think that's an issue. So there's one that I think is really on the cusp of becoming a big thing. And the stuff, if you look at what's just now, the problem with all the generated video clips that people have been seeing, that there were the problems where yes, you can generate something, but you can't get character consistency from one video clip to another. I'm trying to tell a story, but I can't get that same character each time. So that's being huge amounts of progress are made on that. Or it's like, well, you're only generating me a 10-second clip. And there are just a couple of products out this weekend announcing new breakthroughs in how long a clip they can generate and keep consistency. So those things are coming, and exactly who puts what together first in what way, it's going to be more like social organizational issues that are going to take a little while for them to percolate out. But I think there's going to be a lot of demand for that. But along those lines, as a practical matter, it's probably not a great time to be somebody who makes their living as a telemarketer or as a support center phone bank person, because these things are going to be better. I think that phone bank operations in India they're going to be in deep trouble. I expect those to, because people really hate to have to deal with an accent, right? So you have all these people saying, "Oh yeah, and we're good because our support centers are all in the U.S." Well, now both of them are in trouble. There will be very inexpensive things that can do your phone support. How much they can do, like how much can they really solve? There'll be some things where you really need the human, but I think increasingly you'll be talking to the machine, and then it'll escalate to a human if it says, "I don't get this. I got to get my supervisor."
There's also a lot of things that are kind of black swans in a way that we don't know that we're going to have to deal with this because there's something else that's going to happen before that'll be a complete pivot. And one of the things that I think, especially as in the commercial real estate space, when I see all the life science lab space that's been built and been invested in, and then you start thinking like what this could impact as far as making medicine, first of all, diagnosing certain issues or illnesses, and then the medicines that they come up with, from their findings and developing using artificial intelligence. And then maybe that lab space isn't needed for this purpose, but different types of space will be needed for whatever it is, for actually storing the drugs, or maybe they're so efficient so you don't need all that space. And there's just so much going on and how this is going to impact everything. It's hard to know what's next because the next thing could be a complete paradigm shift for everything.
So, okay, so you've now it's too late for you now that you're now talking about what I'm actively working on. So, do there's no hope. You're never going to get me to shut up.
Perfect.
So yeah, we would want to revolutionize the scientific process. We want things to go faster. We want things to go both faster, and we want to have it more things being worked on at once, right? So we get as much of this benefit as quickly as possible. There's justifiably some wonderful attention paid to the Nobel Prize for this thing called AlphaFold that cracked the problem of determining protein structures or predicting protein structures, which is very important in drug design. But that's a very narrow thing. That's solving a particular kind of piece of the puzzle, but it's not automating science. So what does it take to have an AI scientist? What does it take to have a robot scientist? The distinction being the AI scientist is one that is going to look at data and figure out hypotheses about what could be going on, and then say, well, then let's go to the laboratory and test these more things. And then the loop, that's how science works. You come up with hypotheses, you test them. And that's the end I'm working on right now. But how do you get that to actually get to the clinic? So there has to be people actually doing those experiments. You actually physically have to do experiments. And so there's a part of the problem of like, well, we need to automate that. And what is the best path forward? There are people who are building very custom machines that will do a part of the laboratory process. But, if you still have humans in the loop someplace, they're the bottleneck. And so wouldn't it be great if we had a laboratory that was pretty much all robots all the time, and they worked faster, they worked all the time, and they got the science done faster. And so that, so to your office space, clearly around San Diego, you've got all of this laboratory space, and what's going to happen to it? If somebody can crack that problem, one way of cracking it would be humanoid robots that can just go in and do what techs do now. Another interesting way that, I suspect the thing that will really make it sing is not just special purpose robots, and not just humanoid robots, but something out of the box. And one of the things that I would put forward as a potential out of the box thing is, yes, they're kind of humanoid general purpose robots. They're only 12 inches tall. And everything is scaled down to smaller samples, smaller equipment. And I can afford to have 100 laboratories in the same cubic footage that I currently have one. Okay, now we're talking. If you have something like that and you combine it with the thinking part of the science, now we can really rock and roll. You're not necessarily out of the woods here. This is going to challenge society on a very important point, which is, when will you let a drug come to the clinic? And right now, the time between the original research and the time that the drug shows up and is used to treat somebody, past FDA approval, et cetera, we can be talking 12 years, 15 years in the worst cases. And so if we turn on a wonderful world of AI, who knows, maybe even super intelligent AI solving all these problems, we have all these drugs lined up that will fix everything. And great, there's 10,000 of them. And the FDA is able to get about 10 through each year, 10 or 20. And also, if you want to do clinical trials, you'll say, I don't want that drug to come out without a clinical trial. 10,000 drugs, every clinical trial needs hundreds or thousands of people. You could be at a point where yeah, you're out of patients. There aren't people available to do these trials with, and you're out of money. Are you going to? We don't have $100 trillion kicking around to run all these trials. And trials are hugely, hugely expensive. Well, especially the last phase 3 trials where they do a lot of people testing with the drug. So, well, what do we want to do? I think this is going to push us to the a different idea about what we're willing to accept for risk. And because you can say I'm totally risk adverse and I don't want any of these drugs to come to market because they might do harm. On the other hand, hey, every year they're not here, that's another 1,000, 10,000, 100,000 people dying horribly of that disease. I'm not saying I have an answer for that. I'm just saying this is going to be an interesting thing that is thrown into sharp relief. Bright lights are going to shine on it.
And I consider myself naive to the scientific process as it comes to drug discovery and coming to the market, and I'm not an expert whatsoever on it. But I hear things like it takes 5-10 years to get approval for drugs, 12 years. I don't know what that process is like, but I'd imagine many of those things, whether it's testing, whether it's when you mentioned robots, but even if you can say like, okay, this is the data set, and this is the sample size, and you're running these tests based on this and that. I mean, whatever the efficacy percentage needs to be, if you can have something that shows like we've ran in this AI model a billion times this and we're getting 95%, it's like, couldn't that speed things up? I'd imagine if you could get something that could speed up a lot of the things, like, well, you tested to get this against that, and we've ran it so many times, like, okay, that can speed up that process to at least get to the human trials quicker.
Well, I think we can get to the human trials quicker. The problem that's all doable. It's once you start hitting the human trials.
Yeah.
First, you do the basic safety testing on healthy subjects, make sure that if they have doses of this drug, they don't die. And actually, that's preceded by a bunch of animal testing, right? Before you let it be given to people, there's a round of animal testing, and then your phase 1 trial is where you may be trying it with a dozen people, something like that. And if it's promising in that, if it shows a significant effect, then you get a chance to go on to phase 2 and phase 3 trials. But for a major drug, the phase 3 trial can, we could be talking a year, 2 years, and $500 million. So, pharmaceutical companies, right now we have a problem in the US that our payment method for drugs, there isn't a central negotiation point like there is in single payer systems. So the Europeans negotiate with the drug companies hard from the point of view, if you want into Germany, you're going to give us this at this price. And that's great. So they wind up recovering a lot of that research cost on people here where there isn't a single payer. But at the same time, they gotta recover that money someplace. They can't just do this massive clinical trial for free. So you have a long process. But I think you were touching on an idea there, though, of suppose I have simulations.
Yeah.
Okay. At what point?
But depending on the data set, like whatever you're doing, like let's say you're testing this drug on this animal. Let's call it, lab rat or monkey.
Yep.
So you're testing that, but if you can somehow have the data set of what the lab mouse is and this drug, and you have that, and you can run those tests a certain number of times, but maybe that's about the genome of the mouse or
No,
something?
no, you're. I think you're exactly on the right point. That in the in the past, or animal testing's been really important, but there are also massive disconnects. The thing that worked in mice doesn't work in humans, or worse yet, something that was safe in mice turns out to have bad effects in humans. So biology between a human and a mouse is there's an awful lot of overlap. But mice are also, in some ways, very different than people. And so trying to test a cancer drug on a mouse that, like, they only live a couple of years. We get cancer when we're old, mostly. The it doesn't it isn't a simple translation. On the other hand, you can say, all right, can I figure out how to take what happens in the mouse and not just take it as a simple works in the mouse? I'll guess it works in people, but take it as this is what happened in the mouse. Can I predict what will happen in people? And there are lots of people working on that and similar problems. Some of them are applying machine learning techniques. In fact, there's people in my lab, or not that it's not my lab, but in the lab I work in, there are people who are working on stuff like that in order to predict whether this drug is going to work for you, given what your genetics are. Your tumor had these problems. Your tumor is mutated on this and this and this. We're going to make a prediction about these 10 drugs. This one's going to work best. Okay, that's going in that direction of try to predict the outcome based on your genome. And can you use animal data as you start building that model? How do you get that model, what you learned with animals, to transfer over into making predictions about humans? So there's some good possibilities there. And something like that might indeed be the place we go to. We start having good predictive models that we start to trust. At what point will the FDA say, okay, the oracle here, this really smart model says, yep, it's going to, based on this animal data and everything we've learned, it should be fine in people. Will the FDA say, okay, good, go start trying it in the clinic? And that would be something that might start having us radically overturn medicine. But right now, a lot of people look to do things where they find new uses for existing drugs, or they find cocktails of these two drugs together, because those things are stuff that it's already a known thing. It's already gotten past the FDA, and so those things can go into the clinic much, much faster. Especially in cancer, you can have cases where you can try something when all hope is gone. You get to a point with somebody and you say, okay, look, the regular therapies are not working for you, but there's a trial of this idea. Do you want to participate in it? And those can be much more out there because, they didn't have any hope.
And I wonder, and I say I'm sure, but maybe not. But once you have all of the results of these drugs do this, that, these have been the results over time, and you mentioned the different cocktails, there has to be a way for someone to have all that data and then ask the AI, is there something should we be trying here? Is there something we're missing? And have it say, well, based on this data, maybe you should try to do this and that, and have it tell you.
You absolutely can. I think I think that the large language models are going to be good at finding holes in, or finding things that were obvious in the literature, or not obvious. You could deduce from the literature, from all of the knowledge they've eaten, because they've eaten the whole scientific literature. They may be able to come up with some good things like that, but on the other hand, there's going to be stuff that there's just going to need to be more fundamental biology understood. Biology is fantastically complicated.
Yeah, I mean, you can tell I'm just spitballing here. But it's just sometimes I think I see how it's applied to some things, and I'm like, that should be something that it could do, but maybe I'm just simplifying it too much.
I think the hard part is getting the data. That we can get this data now that two people 20 years ago they'd say, "Oh my gosh, how in the world? That's amazing." But in fact, if you try to think of like how much data you actually would want in order to understand what's happening in the tissue inside that mouse as it's actually experiencing live, and not that you had to grind it up to measure that tissue. There's all these things you can't actually see. You can measure certain things, but you can't necessarily see the whole process. And so the more ways that we could devise to measure things, the more that we could do. That's always been the case. You invent the telescope, suddenly the solar system becomes apparent. So we need lots more of those things. You could imagine, supposing I had a whole bunch of sensors that I could put all over a patient who's being treated for cancer or something like that, and moment to moment have this massive stream of data coming out of them of what the chemistry is all over their body. And I don't know how to use all that. If you're sitting there trying to write old-fashioned rules, you said, what are the rules for interpreting that? On the other hand, if you have that data stream, now that's one of those brilliant, huge data streams that you can start feeding into a machine learning environment. And you might get outrageously interesting predictions about what's about to happen to that person and whether are starting to respond to that drug and what will happen next. And so those are places that I think are really important to get to, is to say, how can we take a whole bunch of data, wire somebody up affordably and not too invasively, so that we have the training data to then have these systems maybe make brilliant guesses about us. So that's one thought that I have about that getting the right data to have the machines learn the biology in a way we can't.
Yeah. How do your colleagues and your peers, when you talk to them about, I mean, not science, but artificial intelligence and use, is this a conversation that you have with other folks, or do other people have other thoughts, fears, ideas, excitements about it? Like, what's the general temperature within your peers and colleagues?
Well, I mean, my peers and colleagues are doing various kinds of AI 24/7. Basically, that's really become the unifying theme of the lab. The other people I deal with it is interesting. There's people who I am an evangelist to. It's going to be a while for the scientific community to lean into it. I mean, you'll hear about the people who are leaning in, and they'll get noticed in the literature. They'll get noticed in the media. Like it's possible that you could have heard about stuff that a team from Google have done with patient interviews, and some wonderful results out of that a year or two ago. But there's a lot of people who are, still thinking about the world in the way that they've been thinking about it, and they haven't been asking themselves, how do I leverage this? And the problem is, of course, that you have to go and invest time in figuring out what this emerging thing can and can't do for you. You have to be prepared to be frustrated where you try stuff and it doesn't pan out. On the other hand, I keep having the experiences where suddenly, oh, that's interesting. I suddenly leap ahead and find something that is really working. And it's a lot of a discovery process about these things. People don't know what's in there. A lot of people do think that they have rules inside them. I was actually one of a doctor who's an instructor in one of my classes was talking about how these things aren't going to be able to do the stuff that in particular that he was seeing because, you have to write it all down in rules and it's too hard. And I didn't correct him. It was like, no, that's the whole thing. These don't have rules inside them. And they still can't do everything by any means, but that's not the reason why they can't. This is where I need my AI assistant to stop me from losing the thread.
Well, here's something I'll jump in here and say, because when I see the people, let's talk specifically in commercial real estate. I was at a conference a couple weeks ago, and somebody was giving a talk on AI, and he'd been working in it for years, specifically to the real estate industry. And I was amazed looking in the room with people that just either it was going over their heads or they weren't thinking. But a lot of it is just because I think people specifically that have had success in their careers or they've just been doing things a certain way that aren't necessarily curious or looking for how to make things better, because if it ain't broke, don't fix it, right? Like they've been doing well in their careers and doing things this way, and they hear about this AI stuff and they're like, yeah, okay, yeah, it's cool, neat, right? But like they don't see like how it is transforming so many things. So that's why I'm interested to see like what somebody in that university science setting feel, and it seems like based on what you're saying, it's a very similar mindset. Like this is the way they do things, and they've always done these things, and you're introducing this new technology that I'd go say it's beyond technology. It's a paradigm shift, and they don't necessarily see it because maybe they've just been full steam ahead in their way of thinking.
It's very it's very uneven. There'll be people who are early adopters on some things, but they won't be. They'll have decided that it can't do that, or that's or they'll try something and they will say, well, it didn't write that up very well, or that piece of code had a problem in it, and then they'll walk away.
Yeah.
and instead of saying, wait a second, this is amazing that it did what it did. What are the things that it can do for me now? And where can I get a big multiplier effect? And I told you at the beginning how like this has been what I wanted all this time, right?
Yeah.
So
that's why I've been so excited about this. Yeah.
I'm motivated to go and play with these things and break them and find out the things they can't do, and then be thrilled when they do something. So, I mean, I had something this morning where I'm onto a different plan for how it's not exactly prompting. It's sort of like prompt structures. And it started doing something really good for me. And I got goosebumps. And it was like, oh my gosh. And I'll see whether I'm going to tell you that this panned out, next time we talk. I mean, I may say, well, yeah, I felt the goosebumps then, but that particular thing didn't pan out. But it you go through these moments where suddenly you get a lot more than you were expecting.
Yeah.
And so I think to shift the paradigm to you, I don't know enough about your field to say what would really be a game changer. But you're here at a point where you do know what's important in this field. So ask yourself, if I could have what I wanted, what would blow the doors open here? What would change? What would be a disruptive change for commercial real estate? What are the bottlenecks? What do people really want out of commercial real estate? Asking it that way, and then saying, well, let's see whether these things can do part of that for me or all of it. Ask the question.
Yeah, well, I do. And sometimes it feels like with what I'm doing, it feels like in a way, at first I thought it feels like I'm flying a spaceship when other people are driving a car. But it's more, but sometimes it feels more like I'm flying a spaceship and other people are riding a horse or something, because I often look for things that I try to turn a complaint that I have into a solution. I'm a very, well, why is this so slow? Why is that taking so long? How can I do this faster? And then I look to the resources available. And now that you have all these AI tools, and to your point, not all of them are perfect, but they shift the gear in a way sometimes that's like, oh wow, there's a whole other door behind this door. I'm gonna go a little further and see what else we can find down here. It's so much fun. I'm enjoying it. But
well, what are the successes that you've had? Name something that was a great moment for you that really felt like you were on the spaceship.
Oh man, well, okay. First, I'll say a couple of things. One, just even structuring my thought. Like if I can put something down and I can write out, and this is a very baseline level. I can say like, this is what I'm thinking. This is who I'm talking to. This is my idea. This is what I want to convey. I can put that in there and say, is again to my point about the message. Is there anything that I'm missing? Is there anything that I can? And it helps me think through things. It's almost like a sounding board. And oftentimes it says it better than the way I said it in the first place. And I'm like, yeah, that's what I meant. And I'll have conversations and I'll say something like, oh, they didn't understand what I said. Like maybe I'm just saying it the wrong way. And it's like a translator. It's like, in some ways, it's like an idiot translator where it's saying like, yeah, that's what I meant to say, but it just didn't come out the way that person could hear it. And so that's a very like baseline version of it. Another thing I would say when really a piece when the light bulb went off for me, and this is when I was taking the class and for the AI business certificate, figuring out like who was responsible for what, because commercial leases can be very complex. They're negotiated. There's different points. Who's responsible for this and when. It's like, okay, you got to go in, you got to read all that, and you got to say, okay, this is the term, like the lease term. This is when the responsibility for this kicks in. These are the requirements. These is responsible up to this dollar amount. But you have that, and you can ask, hey, who's responsible for this? And then they would be like, yeah, it's this. And then you can turn that into, you can just have that just bypass me, basically. I'll be there to proof it, but they could submit the information, the question, or, they have a roof leak or what have you. It interprets the lease, say it's the tenant's responsibility. This is why. This is who. This is the insurance requirements for the vendor. And so they can tell you based on the people that you have in your database that are approved vendors, these are the people that you should contact. That one thing saved me, one person as a manager at the time, that saved me like 3 hours. And it could do it in 30 seconds. And it's like, if you multiply that over a portfolio, the time and money savings it's crazy. And just abstracting leases in general, and there are softwares that do that, but can just abstract everything, put that into the database, and then it'll know all those things. Pricing for new contracts. If you know what that, and this has been really fun for me, because sometimes like, why does it take so long to get a proposal to a client? If you know what type of property is, how many, the square footage, the location, the type, the occupancy rate. Why does it take so long to figure out what that is? And now you have that data set, and someone says, "Hey, I got this retail center with this many tenants." Like, you know exactly how much it's going to cost. You know exactly how much it should cost. You know exactly how much it costs in this area versus this other location. And it's mostly for me. I've seen the light bulb go off for me is in the time savings,
Yeah.
and that's time is money. Yeah, I mean, there's so many more things. I use it. I use it for everything. I use it for editing podcasts. I use it for drafting ideas and thinking through things, but also helping proofread things. Everything.
Mm-hmm.
It's
Yeah.
just amazing. It's amazing. And so so when I said like, how are you not using this?
Yeah.
How are
Really.
you not using this? Like I don't get it sometimes, but that's okay. I'll tell people, and sometimes people are like, well, how did you do that? How did you do this? Even everyone knows that there's other things. Here's another one. Here, that you can have like Zoom meetings, and it'll take the transcript, and then it'll give you the summary. Well,
Yep.
also you can do that in other methods where you can just use your voice recorder at a meeting or a lecture, have it record it, and then just take the transcript and say, summarize this for me. And it knows me and knows how I like things and what bullet points and what format and all that stuff. And it'll just give me all the notes. Yeah, it's amazing.
So I'll tell you a couple of them that are like that that have been amazing for me. Is I'm often going to these various talks and seminars, and people are presenting stuff. And first of all, there's a reason I'm a graduate student. There's whole chunks of this stuff I was never trained on that I'm learning now, which is really fun. But that means that there's stuff in these presentations that I'm there saying, okay, I didn't quite get that, or even I'm lost. And now I can use my phone and take a picture of the slide that they're on directly into ChatGPT or into Claude and have it explain it to me. And it just based on those pictures, you can get explanations of really hard stuff. And that you can later, when you have more time, if you really wanted to know it in more detail, then now you can say, okay, now I have time. Really explain it to me. I didn't get all of those terms. First, explain all of that. Oh, I still don't get it. Make me an interactive simulation of that to show, so I understand that point. All out of just taking the pictures of their slides.
Yeah,
it's astounding. But in the real estate related thing, and it's not your piece at all, but just OpenAI released that really beautiful new image generator that can do that everybody was doing Studio Ghibli versions of themselves. So we're buying tile for the kitchen, and I just took a picture of the kitchen, and then we go and look at various tile samples, and I'm saying, okay, like we're going to paint the wall light blue, and let's see what this tile looks like in our kitchen, and this swap this tile in to this picture. And there've always been people trying to do augmented reality stuff to do that kind of stuff for you, or there have been special purpose programs, but this is just like, it's this random thing that I have on my phone all the time now, and it did a pretty good job of helping us figure out how well. Like there was some tile that looked good, we really liked it in the store, and the simulation convinced us that, oh yeah, that would be a bit much if we put it in our kitchen. Let's not go there.
Yeah.
So just little things like that, the little conveniences like that are astounding when you step back and think of it.
It's been a lot of fun playing with all these things, and I know there's going to be some big let's call them repercussions from this, from employment, and again, we go into the black swan pieces, things that we don't know yet. And I understand that, and I try to be cognizant of that. Also, in the meantime, it's so fun to see like this new toy, this new intelligence. Like it really is. It's like a new toy, but a new friend, a lot of things, and it's been really exciting to see. And every day, it feels like I find a new use for it, a new way to test it out, and yeah, it's exciting. Exciting. So what you've been working on for and thinking about and working for over 45 years now is it's happening. So I'm sure
It's
you're very excited about all this.
well, I'm so excited. I just time slips by while I'm at the computer working on the good stuff.
Yeah.
It's just amazing. Um, yep.
Well, Dexter, you've been very gracious with your time. Thank you very much, and congrats on your success. And now getting your doctorate again. Congrats again. That's a really big step, and very cool. Congratulations.
I thank you very much for inviting me, and it's been fun talking to you.
Yeah, it's been fun. Take care.
Yep. Take care. Bye bye.